Hello and welcome to my channel. I am Mensah Augustine and I welcome you to my lesson on complex numbers. This is lesson 1 on how to find the argument of a given complex number. Now let's look at the definition of a the argument of a complex number. We say that the argument of a complex number z visualized in the complex plane is the angle between the real axis and the line joining the point to the origin. So if I draw the complex plane here, this is the positive real axis, this is the positive imaginary axis, this is the negative real axis, and this is the negative imaginary axis. So that is I, the imaginary axis. We are saying that if I visualize a point here, let's say z equal to negative a minus bi, then this is the origin, and this is the line joining the point to the origin. Then the argument of z is the angle you measure from the positive real axis to the line joining the point and the origin. So I'll denote it by alpha. Now let's take examples for us to see. Let's take example 1. That I have z equal to 2 plus root 3i. 2 plus root 3i. Well, how do we find the argument of this? In fact, we'll be taking 7 or 6 examples to establish our stance very well. Now, let us draw the complex plane. If we draw the complex plane, we have the positive real axis and we have the positive imaginary axis. This is the negative real axis and this is the negative imaginary axis. So here we have z equal to 2 plus 3i. The real part of z is 2 and the imaginary part of z is positive 3. So we indicate the real part here, positive 2, sorry, the imaginary part is root 3 rather, and then we indicate here root 3. So if we visualize the point here, or if we take the point here as z equal to 2 plus root 3i, then we join the points to the origin. Then we join it here. And we know that from here to here is root 3, so from here to here is also root 3. Then we take theta. I'm not going to take alpha for now, let me take theta here for now. So it means that the angle from the real axis to the line joining the point to the origin is what we are looking for. So here, let us take the tangent of theta. So if we take the tangent of theta, it is equal to the opposite divided by the adjacent. So we take root 3 divided by 2. Then we take theta to be equal to the arctangent or the tan inverse of root 3 on 2. And I have theta to be equal to, I have my calculator here. So you set your calculator into radians. So you point shift tan inverse of root 3 on 2. And that will give us 0.7137 in radians. So that is the argument. So here the argument of z is equal to 0.7137, or you can write it as the argument of 2 plus root 3i is equal to 0.7137 in radians. Now let's take the next example. The next example, we are going to consider z equal to root 2i. Z equal to root 2i. Now, if we consider z equal to root 2i, let us draw the complex plane. Now, if this is the complex plane, we have the x, the real axis, the imaginary axis, that's the positive side, the negative real axis, and the negative imaginary axis. This is the negative imaginary axis. Now, we have z equal to root 2. If you compare this to z equal to a plus bi, then the real part is 0 and the imaginary part is positive root 2. So this is the positive imaginary part. Then it means that z at this point is equal to root 2. So we put root 2 here. So this is the line joining the origin and the point. So we measure from the positive real axis to the line. And what is the angle here? The angle here is 90 degrees, or it is pi in radians. So here the argument of z is equal to it's equal to pi on 2 radians. It is pi on 2 radians. From here to here is 90 degrees, and 90 degrees is the same as pi, which is equal to 180 degrees divided by 2 in radians. Very simple as that. Now let's take the next example. In the next example, we are going to consider z equal to root 3 minus I. Root 3 minus I. So, in this case, we are considering the real part to be positive and the imaginary part to be negative. So we can take z equal to, let's say, 5 minus 2i, z equal to 8 minus 3i, or any negative. So the real part is positive and the imaginary part is negative. So if this happens, this is how we do it. So we draw the complex plane, positive real axis, positive imaginary axis, negative real axis, and then the negative imaginary axis is here. So what do? We are to do this one. The real part is positive. So what do? The real part is positive. So here we put a positive root 2. Sorry, positive root 3 here. And the imaginary part is negative. So this is the negative imaginary part, and it is what? 1. So we put 1 here. So if we visualize z to be at this point, we have root 3 minus I. So we join the point to the origin. Very simple. And what is the angle that we are looking for? We are looking for this angle. So now I will do it as phi. We are looking for, alpha. We are looking for alpha. So let's put theta here. Let me join this to this. And we know that here is 90 degrees. Very simple as that. So let us find tan theta. So if we take the tangent of theta, it is equal to root 3 divided by 1. Because from here to here is root 3. 1 divided by root 3 rather. Because from here to here is 1. That's the same as from here to here. So theta will now be equal to the tangent inverse of 1 on root 3. And what will that give? We have the tangent inverse of 1 divided by root 3. And that is pi on 6. That is pi on 6. So here we have theta to be equal to pi on 6. And here how do we represent the angle? We want the angle from the positive real axis to the line joining the origin and the point. So if I move from here and end up here, it is 360 degrees or 2 pi in radians. So since I have this as pi on 6, I will take pi on 6 from 2 pi to get this. So here I'm going to write the argument. Okay, let's write alpha because I've used alpha there. Alpha to be equal to 2 pi minus pi on 6, and that will give me 11 pi on 6 in radians. From here to this point again is 2 pi or 360 degrees. So we are taking the 2 pi in radians. So if I move from here, that is alpha plus theta is equal to 2 pi. Now I know theta, so I have alpha plus pi on 6 equal to 2 pi. And what do? If I want alpha, I'll write 2 pi minus alpha on 6, and that will give me 11 pi on 6 in radians. Now, we can also solve this one in a different way, so let's start that different way and see. You see that here we have -1 as the negative as the real number, the imaginary part is -1. So you can also take the tangent of theta to be equal to -1 divided by square root of 3. And here theta is equal to the tangent inverse of -1 on root 3. And I have theta to be equal to -pi on 6. Now, if we look at this one, this is a negative angle. Very simple as that. So we are not going to subtract it from 2 pi, but we are going to write our alpha equal to 2 pi plus -pi on 6. And this will give us the same 2 pi on 6 minus pi, 2 pi minus pi on 6, and it will be back to 11 pi on 6 as we've done here. So if you use the negative sign, it means that you are going to add it. In this case, you are going to add it. So you apply the same formula to this, the same formula to this, and the same formula to any complex number that has a positive real part and a negative imaginary part. So you can solve it this way or that way. Very simple as that. Now let's move on to the next one. So here we are going to consider z equal to -5. Z equal to -5. Now if you consider z equal to -5, if you compare it with z equal to a plus bi, we have the real part to be -5 and the imaginary part to be 0. So if we draw the complex plane, we have the imaginary part, the positive imaginary part, and then the positive, the positive real part and the positive imaginary part. And here is the negative real part. So we put -5 here. Very simple. So there's a line joining z and the origin. So we measure from here pi on 2 to here, that is pi. Very simple as that. So here the argument of z is equal to pi. Very simple as that. So if I take, let's say z equal to -3, z equal to -7 on 8, the argument of these will always be what? Pi. That is the argument of z, where z is equal to a real number, is always pi. Very simple. Now let's take another example. I think we have done with this quadrant, we have done with this, we have done here, and we have done here. So we are coming to this quadrant, and then you come to what lies on this line. So let's move on. Now let's take the argument of z equal to -3 plus 2i. So here what we see, If we draw the complex plane, the positive real axis, the positive imaginary axis, the negative real axis, and then the negative imaginary axis. So we have negative 3, so we put negative 3 here. So negative root 3 here. And we have positive. So we put 2 here. That is the imaginary part. And if we say that that is z equal to negative root 3 plus 2i, then we join it to the origin. We have this, then you put this one here. You bring theta. So let's calculate for theta. So if we take the tangent of theta, it is equal to the opposite. That is from here to here is 2. So we take 2 divided by root 3. Or we can take the tangent of theta to be equal to 2 divided by square root of negative square root of 3. Any of them. So I think we've done this one earlier. We have shift tan inverse of 2 on root 3 to be equal to 0.8. So here we are getting theta to be equal to 0.8571. And here we are going to get this to be equal to negative 0.8571. Very simple as that. So here, if we take this direction, the angle that we are looking for, or the argument, is from here, from the positive real axis to the line joining Z and then the center. So we are looking for alpha. So if we take this path, we are going to take alpha to be equal to, now here, alpha plus theta will give us 180. So if I want alpha, I will take theta from 180, or pi. So here alpha will be giving us pi minus 0.8571. And then here we are going to get 2.2845 in radians as alpha. Hence, the argument of z is equal to 2.2845 in radians. Or you can write it as the argument of minus root 3 plus 2i is equal to 2.2845 in radians. Very simple as that. Now, if we take this part, we are going to get negative. And if we get that one, we are not going to subtract it as we did here, but we are going to write our alpha to be equal to pi plus negative 0.8571. And this will give us the same answer as 2.2845 in radians. So take note, if you are in this quadrant or you are in this quadrant, you can take the negative sign. If you take the negative sign, you add. If you take the positive, you are going to do what? Subtract. Very simple. So I hope you've done it here, 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 here. So we are coming to this point, and we are also done here. So now let us take, for instance, we are going to take z, that is z, equal to negative root 13i. So this is the positive real axis, positive imaginary axis, negative real axis, and negative imaginary axis. So negative root 13 will lie here. So negative root 13. So what do we do? We said that the argument of z is the angle between the positive real to the line joining z and then the center, within the center. So you want this angle, alpha. So how do we calculate that angle? We have negative root 13, and this is x. So we measure from here to here is pi on 2. From here to here is pi. From here to here is also pi on 2. So pi plus pi on 2. Pi plus pi on 2 will give us 3 pi on 2. So let's clean this. From here straight to this line is pi, and from here to here is 90 degrees, but in radians it is pi on 2. So if you add pi to pi on 2, you are going to get 3 pi on 2. So here the argument of negative root 13 I is equal to 3 pi on 2, or the argument of z is equal to 3 pi on 2. So this implies that whenever you have the complex number z equal to negative imaginary parts or negative imaginary number, then you are going to get the argument always to be 3 pi on 2. So for instance, if I write z equal to negative I, the argument will be this. If I write z equal to negative 9i, the argument will still be this. Thank you for watching, and please subscribe to my channel. You can follow me on my Facebook page, Maths with Vim. If you have any question related to this, leave it at the comment section and I'll be of help to you. Bye bye.